So, question 9, set 31. This is another of those redox titration type questions, and you won't get one as hard as this, but you may be required to do the calculations once they give you the formulae for it. Sorry, not the formulae, the equations for it. So let's have a look at it. We're interested in how much chromium is present in a mineral, and this is done by converting a known mass of sample into sodium dichromate. How? They don't tell you, and we don't care. All we need to know is that chromium is all converted to dichromate, which is implied in this, and we can then follow the amount of chromium in the dichromate. Once we got dichromate, we can titrate an acidified solution of the sodium chromate with a standard solution of iron 2 sulfate. In other words, we're doing a redox titration. And by figuring out how much iron 2 sulfate we've got, we can then use the equation to calculate how much dichromate we have. Okay, and then once you've got that, that solves the problem. Okay, let's put this together. We're told that dichromate in an acidified solution takes 6 electrons to produce 2 chromium, 3 plus and 7 water. This is from the redox table in the back of your book. You would always have that as in a data sheet. Iron 2, however, reacts to produce iron 3 with dichromate and an electron. We use our techniques of balancing redox equations. We have 6 electrons here and only 1 here. So what we need to do is we need to scale the bottom one by 6 to get so that we can put together an overall equation which will let us do the stoich on this. So here's what happens. We can take our the stuff that we have here, the dichromate, the hydrogen, and in addition to that we can add our iron 2 to it, like so. Now, and what we find on that is that produces this side of the equation and this side of the equation. I better put the plus. Now remember that we scaled this side by 6, so we're going to have to put 6 of those guys in, and that means that 6 of those guys are together, and now we have a fully balanced redox equation, equation which shows us what's going on there. So we now know that by reacting iron with it, it took a total of something like what was it, 37.5 milliliters of this 0.4 molar solution. So let's have a look. The number of moles of iron required was equal to 0.0375 times 0.4, that's 0.4 molar, that's 37.5 mils. Now let's change it from iron. Let's go straight to the chase. Dichromate. Let's go for chromium, because that's the one we're interested in. The number of moles of chromium equals the number of moles of iron times the ratio of iron to chromium in here. So we have 6 iron to 1 dichromate times 2, because for every dichromate we get 2 of these we get 2 of these chromiums produced. Sorry, I've got that the wrong way around. Let me just sort that out. Okay, so in other words, for every 1 chromium dichromate we have, we get 2 chromiums. For every 1 dichromate we have 6 ions. So we have to multiply the number of ions by 1 divided by 6, And then because we get 2 chromiums, we've got to multiply that by 2. This all comes out to be the remarkably round and friendly looking 10 to the minus 3 moles. 10 to the minus 3 moles. I'll just make the minus 3 a superscript. Beautiful. So that's how much chromium we have. We need to know mass percentage. So what we now must do is we convert that number of moles into a mass. So n number of moles equals, mass equals n times Mr. molecular mass, which is equal to this guy up here, times the atomic mass of chromium, which is 52.00. And all of that gives us a value of 0.26 grams. Now we have all the pieces we need to do our percentages. We can say then that the percentage of chromium in sample equals mass of chromium divided by mass of sample and multiplied by 100% because it's a percentage. And if you crack the numbers through on that, you get 0.26 divided by 1.27, and that equals 20.47%. And you round that appropriately to whatever you like, or if you like 20.5%. And that's how to do that type of problem. Remembering again, you're not likely to see too many of those, or if you do, this part of the problem will be given to you. Okay, I hope that helps.